Nevertheless, the team pressed ahead, and the Power Jet's Whittle unit, or WU, engine began test runs on the 12th of April, 1937. Initially, the WU showed an alarming tendency to race out of control, due to issues with the fuel injection, before stable speeds were reached. However, by August, Whittle acknowledged a major reconstruction effort was needed to solve the combustion problem and compressor efficiency. On the 9th of July, Falke and partners gave the company an emergency loan of £250. On the 27th of July, Falke's option expired, but they agreed to continue financing Power Jets by loan. Also in July, Whittle's postgraduate stay at Cambridge was over, but then he was placed on the special duty list so he could work full-time on the engine. On the 1st of November, Williams, Tinling and Whittle took control of Power Jets. Whittle was promoted to squadron leader in December. Tizard pronounced it streaks ahead of any other advanced engine he had seen, and managed to interest the Air Ministry enough to fund development with a contract for £5,000 to develop a flyable version. However, it was not until March 1938 that a contract was signed, when Power Jets became subject to the Official Secrets Act, limiting the ability to raise additional funds. In January 1938, BTH invested £2,500. In December 1937, Victor Crompton became Power Jet's first employee, as an assistant to Whittle. Because of the hazardous nature of the work being carried out, development was moved largely from Rugby to BTH's lightly used Ladywood foundry at nearby Lutterworth in Leicestershire in 1938. Tests with a reconstructed WU engine commenced on the 16th of April, 1938, and proceeded until a catastrophic failure of the turbine on the 6th of May. Yet, the engine ran for 1 hour and 45 minutes, and generated a thrust of 480 pounds-force, 2,100 N, at 13,000 rpm. Another WU engine reconstruction was started on the 30th of May, 1938, but using 10 combustion chambers to match the 10 compressor discharge ducts. Avoiding a single large combustion chamber made the engine lighter and more compact. Tests commenced with this third WU on the 26th of October, 1938. These delays and the lack of funding slowed the project. In Germany, Hans von Ahane had filed for a patent in 1935, which in 1939 led to the world's first flyable jet aircraft, the Heinkel He 178, powered by the Heinkel He's 3. There is little doubt that Whittle's efforts would have been at the same level or even more advanced had the Air Ministry taken a greater interest in the design. When war broke out in September 1939, Power Jets had a payroll of only 10 and Griffith's operations at the Ray and Metropolitan Vickers were similarly small. Whittle's smoking increased to 3 packs a day and he suffered from various stress-related ailments such as frequent severe headaches, indigestion, insomnia, anxiety, eczema and heart palpitations, while his weight dropped to 9 stone. 126 pound/57 kilograms. To keep to his 16-hour workdays, he sniffed Benzedrine during the day and then took tranquilizers and sleeping pills at night to offset the effects and allow him to sleep. He admitted later he had become addicted to Benzedrine. Over this period he became irritable and developed an explosive temper. Changing Fortunes, edit. On the 30th of June, 1939, Power Jets could barely afford to keep the lights on when yet another visit was made by Air Ministry personnel. This time Whittle was able to run the third reconstructed WU at 16,000 rpm for 20 minutes without any difficulty. One of the members of the team was the Director of Scientific Research, David Randall Pye, who walked out of the demonstration utterly convinced of the importance of the project. The ministry agreed to buy the WU and then lend it back to them, injecting cash, and placed an order for a flyable version of the engine, referred to as the Power Jets W.1 and Power Jets W.2. By then, the ministry had a tentative contract with the Gloucester Aircraft Company for a simple aircraft specifically to flight test the W.1, the single-engine Gloucester E.28/39. Whittle had already studied the problem of turning the massive WU into a flyable design, with what he described as very optimistic targets, to power a little aeroplane weighing 2,000 pounds with a static thrust of 1,389 pounds. The designed maximum thrust for the W.1 was 1,240 pounds force, 5,500 N, while that for the W.2 was 1,600 pounds force, 7,100 N. The W.2 was to be flown in the twin-engine Gloucester Meteor fighter, at the time known by its Air Ministry specification as the F.9/40, but the engine was replaced with the W.2B, having a designed static thrust of 1,800 pounds force, 8,000 N. An experimental version of the W.1, designated W.1X, was used as a mock-up for the E.28 installation. A second E.28 was powered by the W.10, that incorporated W.2 features such as air cooling of the turbine and a different compressor intake. On the 26th of March, 1940, the jet engine was listed as a potential war winner by Air Marshal Tedder, and given the associated priority. Power Jets also spent some time in May 1940 drawing up the W.2Y, a similar design with a straight-through airflow that resulted in a longer engine and, more critically, a longer drive shaft but having a somewhat simpler layout. To reduce the weight of the drive shaft as much as possible, the W.2Y used a large diameter, thin-walled, shaft almost as large as the turbine disc, necked down at either end where it connected to the turbine and compressor. In April, the Air Ministry issued contracts for W.2 production lines with a capacity of up to 3,000 engines a month in 1942, asking BTH, Vauxhall and the Rover Company to join. However, the contract was eventually taken up by Rover only. In June, Whittle received a promotion to wing commander. On the 19th of July, 1940, Power Jets abandoned effort to vaporize fuel, and adopted the controlled atomizing burner for the combustion chamber, developed by Isaac Lubbock of Asiatic Petroleum Company, a joint venture of Shell and Royal Dutch. In the words of Whittle, the introduction of the Shell system may be said to mark the point where combustion ceased to be an obstacle to development. The size of Power Jets also increased with the war effort, increasing from 25 employees in January 1940 to 70 in September 1940. Rover, edit. Meanwhile, work continued with the WU, which eventually went through 9 rebuilds in an attempt to solve the combustion problems that had dominated the testing. On the 9th of October the WU ran once again, this time equipped with Lubbock or Shell atomizing burner combustion chambers. Combustion problems ceased to be an obstacle to development of the engine, although intensive development was started on all features of the new combustion chambers. By this point it was clear that Gloucester's first airframe would be ready long before Rover could deliver an engine. Unwilling to wait, Whittle cobbled together an engine from spare parts, creating the W.1X, X standing for experimental, which ran for the first time on the 14th of December, 1940. Shortly afterwards an application for a U.S. patent was made by Power Jets for an aircraft propulsion system and power unit. The W.1X engine powered the E.28/39 for taxi testing on the 7th of April, 1941 at Brockworth near the factory in Gloucester, where it took to the air for 2 or 3 short hops of several hundred yards at about 6 feet from the ground. The definitive W.1 of 850 lbf, 3.8 kN, thrust ran on the 12th of April, 1941, and on the 15th of May the W.1 powered E.28/39 took off from Cranwell at 7:40 p.m., flying for 17 minutes and reaching a maximum speed of around 340 miles per hour, 545 kilometers per hour. At the end of the flight, Pat Johnson, who had encouraged Whittle for so long, said to him, "Frank, it flies." Whittle replied, "Well, that's what it was bloody well designed to do, wasn't it?" Within days the aircraft was reaching 370 miles per hour, 600 kilometers per hour, at 25,000 feet, 7,600 m, exceeding the performance of the contemporary Supermarine Spitfire fighters. Success of the design was now evident, and in 1941, Rolls-Royce, Hawker Siddeley, the Bristol Aeroplane Company, and de Havilland became interested in gas turbine aircraft propulsion. Under Harold Roxby Cox, the Gas Turbine Collaboration Committee was created to give a forum for all the companies for exchange of information. The stress on Whittle was expressed in a 27th of May, 1941 letter to Henry Tizard. "The responsibility that rests on my shoulders is very heavy indeed. We are faced with 2 alternatives: either we place a powerful weapon in the hands of the Royal Air Force, or, if we fail to get our results in time, we may have falsely raised hopes and caused action to be taken which may deprive the Royal Air Force of hundreds of aeroplanes that it badly needs." The W2/700 engine, or W.2B/23 as it was known to the Air Ministry. It was the first British production jet engine, powering early models of the Gloucester Meteor. In mid-1941, relations between power jets and Rover had continued to deteriorate. Rover had established a version of power jets set up at Waterloo Mill, associated with their Barnoldswick factory, near Clitheroe. Rover was working on an alternative to Whittle's reverse flow combustion chambers, by developing a straight-through combustion chamber and turbine wheel. Rover referred to the engine as the B.26, sanctioned by the Directorate of Engine Development, but kept secret until April 1942, from Power Jets, the Controller of Research and Development, and the Director of Scientific Research. Rolls-Royce, edit. Earlier, in January 1940, Whittle had met Dr. Stanley Hooker of Rolls-Royce, who in turn introduced Whittle to Rolls-Royce board member and manager of their Derby factory, Ernest Hives, later Lord Hives. Hooker was in charge of the supercharger division at Rolls-Royce Derby and was a specialist in fluid dynamics. He had already increased the power of the Merlin piston engine by improving its supercharger. Such a speciality was naturally suited to the aerothermodynamics of jet engines, in which the optimization of airflow in compressor, combustion chambers, turbine and jet pipe is fundamental. Hives agreed to supply key parts to help the project. Also, Rolls-Royce built a compressor test rig which helped Whittle solve the surging problems, unstable airflow in the compressor, on the W.2 engine. On the 10th of December, 1941, Whittle suffered a nervous breakdown, and left work for a month. However, by the end of January, 1942, Power Jets had 3 W.2B engines, 2 built by Rover. In February, 1942, flight trials of the W.1 engine began in the E.28, which reached 430 miles per hour. 690 kilometers per hour, at 15,000 feet, 4,600 m. On the 13th of March, 1942, Whittle started work on a redesign of the W.2B, referred to as the W.2/500. On the 13th of September, 1942, W.2/500 performance tests matched predictions, showing a thrust of 1,750 pounds force, 7,800 N, at full speed. In October 1941, the Ministry approved a new factory to be built outside Whetstone, Leicestershire. From the 3rd of June until the 14th of August 1942, Whittle visited the United States. At the General Electric's Lynn factory, Whittle reviewed the Type I supercharger, GE's code name for their jet engine, based on PowerJet's W.1X. An improved version of the W.2B would also be built, called the I-16, incorporating features of the W.2/500. Whittle also toured the Bell aircraft, and the 3 Bell XP-59 Aeracomets, a twin-engine fighter powered by the General Electric IA jet engines. This fighter took flight in October 1942, 1 year and 1 day after GE received PowerJet's W.1X. On the 11th of December 1942, Whittle had a meeting with the Chief Executive of the Ministry of Aircraft Production, Air Chief Marshal Wilfred Freeman, and Air Marshal Francis Linnell, Controller of Research and Development at MAP. According to Whittle, he made it clear that he had definitely decided to transfer Barnard Swick and Clitheroe to Rolls-Royce management. Spencer Wilkes of Rover met with Hives and Hooker at the Swan and Royal Pub, in Clitheroe, near the Barnard Swick factory. By arrangement with the Ministry of Aircraft Production, they traded the jet factory at Barnard Swick for Rolls-Royce's tank engine factory in Nottingham. Testing and production ramp-up was immediately accelerated. Adrian Lombard, Rover's supervising engineer on the Whittle engines, transferred to Rolls-Royce to continue the role. By January 1943, Rolls-Royce had achieved 400 hours of run time, 10 times Rover's number of the previous month, and in May 1943, the W.2B passed its first 100-hour development test at 1,600 pounds force, 7,100 N, of thrust. When Rolls-Royce became involved, Ray Doy, the manager of the company's flight centre at Hucknall Airfield on the north side of Nottingham, had a Whittle W.2B engine installed in the rear of a Vickers Wellington bomber. The installation was done by Vickers at Weybridge. From the end of 1937, when a squadron leader, he lived at Broomfield on Bilton Road, in Rugby. Both sons were at school in the town. He later briefly lived at Laurel Croft, 1 North Street, Kilsby, until 1949. His 2 sons went to Rossall School in Blackpool. Ian later joined the RAF. Continued impact, edit. Whittle wanted to improve the efficiency of the jet engine at lower speeds. According to Whittle, I wanted to gear down the jet, i.e. to convert a low-mass high-velocity jet into a high-mass low-velocity jet. The obvious way to do this was to use an additional turbine to extract energy from the jet and use this energy to drive a low-pressure compressor or fan capable of breathing far more air than the jet engine itself and forcing this additional air rearwards as a cold jet. The complete system is known as a turbofan. The first embodiment was referred to as a no-1 thrust augmenter, which consisted of an aft fan, or additional turbine, in the exhaust of the main engine. In 1942, no-2 augmenter, a conventional 2-stage system with the fan blades external to the turbine blades, was used by GE in the Convair 990 Coronado. A no-3 augmenter, known as the tip turbine, had the turbine blades outside the fan. A no-4 augmenter, in combination with the W2/700, included an afterburner and was the design power plant for the Miles M.52 project. According to Whittle, the first attempt at the turbofan proper, i.e. having the fan ahead of and supercharging the core engine, was the LR-1 intended as the power plant of a four-engined bomber for operations in the Pacific. The mass flow through the fan of the LR-1 was to have been 3-4 times that through the core engine, i.e. the bypass ratio was 2-3. Filed in March 1936, Whittle's main turbofan patent 471,368, expired in 1962. Whittle's work had caused a minor revolution within the British engine manufacturing industry and, even before the E.28/39 flew, most companies had set up their own research efforts. In 1939, Metropolitan Vickers set up a project to develop an axial flow design as a turboprop but later re-engineered the design as a pure jet known as the Metrovic F.2. Rolls-Royce had already copied the W.1 to produce the low-rated WR.1 but later stopped work on this project after taking over Rover's efforts. In 1941, de Havilland started a jet fighter project, the Spider Crab later called Vampire, along with their own engine to power it, Frank Halford's Goblin, Halford H.1. Armstrong Siddeley also developed a more complex axial flow design with an engineer called Hepner, the ASX, but reversed Vickers' thinking and later modified it into a turboprop instead, the Python. The Bristol Aeroplane Company proposed to combine jet and piston engines but dropped the idea and concentrated on propeller turbines instead. Nationalization, edit. During a demonstration of the E.28/39 to Winston Churchill in April 1943, Whittle proposed to Stafford Cripps, Minister of Aircraft Production, that all jet development be nationalized. He pointed out that the company had been funded by private investors who helped develop the engine successfully, only to see production contracts go to other companies. Nationalization was the only way to repay those debts and ensure a fair deal for everyone, and he was willing to surrender his shares in Power Jets to make this happen. In October, Cripps told Whittle that he decided a better solution would be to nationalize Power Jets only. Whittle believed that he had triggered this decision, but Cripps had already been considering how best to maintain a successful jet program and act responsibly regarding the state's substantial financial investment, while at the same time wanting to establish a research center that could use Power Jet's talents, and had come to the conclusion that national interests demanded the setting up of a government-owned establishment. Within the map there was a feeling that Power Jets was effectively a research unit funded by the Treasury and that management within the company was non-existent. The latter was also expressed by workers at Power Jets. On the 1st of December, Cripps advised Power Jets directors that the Treasury would not pay more than £100,000 for the company. In January 1944, Whittle was appointed a Commander of the Order of the British Empire in the New Year Honours. By this time he was a group captain, having been promoted from Wing Commander in July 1943. Later that month, after further negotiations, the ministry made another offer of £135,500 for Power Jets, which was reluctantly accepted after the ministry refused arbitration on the matter. Since Whittle had already offered to surrender his shares, he would receive nothing at all, while Williams and Tinling each received almost £46,800 for their stock, and investors of cash or services had a threefold return on their original investment. Whittle met with Cripps to object personally to the nationalization efforts and how they were being handled, but to no avail. The final terms were agreed on the 28th of March, and Power Jets officially became Power Jets, Research and Development, Limited, with Roxby Cox as chairman. Constant of Ray head of engineering division, and Whittle as chief technical advisor. On the 5th of April, 1944, the ministry sent Whittle an award of only £10,000 for his shares. Whittle and other Power Jets staff still held the view that they would be the sole designers of jet engines. They would build prototypes and industry would actually produce them. This view was in conflict with that of the engine companies, which in engine design had already achieved competence similar or superior to that of Power Jets. The engine companies stated they would not work with Power Jets if Power Jets were the sole designers. The government scientists from Ray who had been moved to Power Jets were against it also, and within MAP there was a feeling that Power Jets was publicly financed but not under public administration. From the end of March, Whittle spent 6 months in hospital recovering from nervous exhaustion. He resigned from Power Jets, R&D, Limited in January 1946. In July the company was merged with the gas turbine division of the Ray to form the National Gas Turbine Establishment, NGTE, at Farnborough. 16 Power Jets engineers, following Whittle's example, also resigned. Whittle's Rolls-Royce_Nene would be licensed and made in 2 different countries, in the United States as the Pratt & Whitney J42 jet engine, later incorporated into the Grumman F9F Panther, and in the USSR Soviet as the Klimov VK1 jet engine, later incorporated into the MiG-15. The Panther vs the MiG-15 would meet in air battles during the Korean War. After the war, edit. In 1946, Whittle accepted a post as technical advisor on engine design and production to Controller of Supplies, Air, was made a commander of the U.S. Legion of Merit, and was appointed a Companion of the Order of the Bath in 1947. During May 1948 Whittle received an ex gratia award of £100,000 from the Royal Commission on Awards to Inventors in recognition of his work on the jet engine, and 2 months later he was made a Knight Commander of the Order of the British Empire. During a lecture tour in the US, Whittle again broke down and retired from the RAF on medical grounds on the 26th of August 1948, leaving with the rank of Air Commodore. He joined Bork as a technical advisor on aircraft gas turbines and traveled extensively over the next few years, viewing jet engine developments in the United States, Canada, Africa, Asia and the Middle East. He left Bork in 1952 and spent the next year working on a biography, Jet, the Story of a Pioneer. He was awarded the Royal Society of Arts Albert Medal that year. Returning to work in 1953, he accepted a position as a mechanical engineering specialist with Shell, where he developed a new type of self-powered drill driven by a turbine running on the lubricating mud that is pumped into the bore during drilling. Normally, a well is drilled by attaching rigid sections of pipe together and powering the cutting head by spinning the pipe from the surface, but Whittle's design removed the need for a strong mechanical connection between the drill and the head frame, allowing for much lighter piping to be used. He gave the Royal Institution Christmas lectures in 1954 on the story of petroleum. Turbine drilling is best used for drilling hard rocks at high bit RPM with diamond-impregnated bits and can be used with an angled drive shaft for directional drilling and horizontal drilling. It competes, though, with Moino motors and increasingly with rotary steerable systems and is again out of favor. Whittle left Shell in 1957 to work for Bristol Aero Engines, who picked up the project in 1961. Setting up Bristol Siddeley Whittle Tools to further develop the concept. In 1966 Rolls-Royce purchased Bristol Siddeley, but the financial pressures and eventual bankruptcy because of cost overruns of the RB211 project led to the slow wind down and eventual disappearance of Whittle's turbo drill. The concept eventually reappeared in the West in the late 1980s, imported from Russian designs. Russia needed the technology because it lacked high-strength drill pipe. As part of his socialist ideals, he proposed that power jets be nationalized, in part because he saw that private companies would profit from the technology freely given during the war. By 1964, he had deserted his previously socialist beliefs, going so far as to launch a fierce attack on the Labour candidate in Smethwick. In 1960, he was awarded an honorary degree, Dr. Tech. Honoris Causa, at the Norwegian Institute of Technology, later part of Norwegian University of Science and Technology. In 1967, he was awarded an honorary degree, Doctor of Science, by the University of Bath. That year, he was inducted into the International Air and Space Hall of Fame.